Hello everyone. The title of this video is Determine the values for which a rational expression is undefined. So in this video I'll be going over many examples in which we're given a rational expression. And a rational expression is simply a fraction where the numerator and denominator are polynomials. And we'll be asked to just simply find the values of whatever variables are in the rational expression, find the values that will make that expression not defined or undefined. Alright, so all the exercises I'm going to do in this video are taken directly from a free online textbook at openstacks.org, and that book is their Intermediate Algebra 2nd edition. And I'm specifically here in section 7.1, titled Multiply and Divide Rational Expressions. The exercises I'm going to be doing in this video are under the heading Determine the values for which a rational expression is undefined, exercises 1 through 4, and I'm going to be doing parts A, B, and C for all 4 problems. So in the video, example 1 will correspond to number 1 part A, example 2 will be number 1 part B, etc., all the way down to I'll have example 12 is number 4 part C. So if you'd like to skip around, if you'd like to see any particular exercise, just count how many examples that would be and look for that example in the timestamps in the description of the video. I do have timestamps for when each example starts. For example, if you wanted to see number 4 part B, that would be the 11th example. So just click on the timestamp for example 11 in the description. Alright, and as I try to say every video, when I start a new example, pause the video and try to figure it out yourself. Try to do things yourself before you see me do it. Because if you're just watching me do it and not doing anything yourself, you're not going to learn anything. So try doing it yourself and then watch how I did it and compare, your way to my way, see how you're doing, see how things are coming along for you. Alright. So let's get into example. Again, example 1 is number 1 part A. Alright, I've put 4 examples up on each page. Alright, so again, the instructions are: determine the values for which this rational expression is undefined. So the key thing we have to remember here is that you can't divide by 0. Dividing by 0 is an undefined operation. So you can't divide by 0. In other words, 0 can never be the value of a denominator. Alright? Because when you see a fraction, that's division. So for example 1, this is 2 times x squared in the numerator divided by, and then z in the denominator. So this expression has a value for any choice of x and z except 1. Right? So I'm going to grab a new piece of paper here, right? My expression, right, 2x squared divided by z, this has a value, a defined value for almost, I should say almost, any choice of the variables x and z. All right, for example, if I replaced x with 1 and z with 2, you'd have the expression's value would be 2 times 1 squared divided by 2. And this would just simply be 1. This expression would represent the number 1 when x is 1 and z is 2. Again, I could go all day long with this. When x is 0 and z is 5, I'm picking just random values for x and z. The value of this expression would be 2 times 0 squared in the numerator divided by 5, and I'd end up with 0 divided by 5, which is 0. So the value of this expression represents the number 0 when x is 0 and z is 5. And like I said, I could do this all day long. There are infinitely many choices for x and z. And for, again, almost all of those choices, for a lot of those choices, the value of this expression is defined. It's 1, or it's 0, or it's 13, or whatever. All right? But it won't be defined whenever the denominator is 0. Right? So for example, here's another choice of x and z. Say I let x be 3 and z be 0. See what happens. We'd have 2 times 3 squared divided by z, and z is 0. So we'd have 18 in the numerator divided by 0. This is bad, right? You can't divide by 0. You can't have 0 in any denominator of a fraction. So this is undefined, and I'm hoping that you can see that the value of this expression would be undefined whenever we choose z to be 0. X can be anything I want, but this is going to be undefined whenever I choose z to be 0. And that's the key to all these problems. You're going to ask yourself when, for what values, when is the denominator of these fractions, right, what you're dividing by, equal to 0? And solve this equation. Right, you're going to set up this equation, set the denominator equal to 0, and solve that equation. And those values you find are going to be the values that aren't allowed, because if you plug them in, you'll be dividing by 0. So for this first one, very simple. Take the denominator, set it equal to 0, and solve. Well, that's already solved. So z equals 0 makes the expression undefined. And I'm not going to write this for every single one here. I'm just going to write it for this first example. All right. When I replace z with 0, I have a fraction in which I'm dividing by 0, and that's bad. And that's all we're asked to do. Right? Determine the values for which the expression is undefined. For this first one, it's when z is 0. I can replace z with any other number, and I can replace x with any number I want, and it'll be fine. Just when z is 0, we're dividing by 0. I know I said that several times now, but I really want to hammer that point home. You can't divide by 0. Denominators can never be 0. Okay, so hopefully that'll make the rest of these very simple. Now I am going to be assuming that you know how to solve polynomial equations and factor. Right, I'm not going to go into all the factoring methods for the methods for factoring polynomials because I'm assuming you've got that knowledge already at this point. All right, so the next expression, the numerator is 4p minus 1 divided by, and then the denominator is 6p minus 5. So again, I could replace p with almost anything I want, and this fraction would represent some number, some defined value. But when it won't be defined, when I can't say what value this represents, is when the denominator is 0. So again, the question is, when is the denominator 6p minus 5 equal to 0? And that'll be the value I can't use, or those will be the values I can't use, right? Because you may have more than one value that makes the denominator equal 0. Well, this one, there's only one value right now. Again, I just solve this equation for p. Add 5, divide by 6. We have p equals 5/6. And there you go. This value is what they're asking us for. If you were to replace p with 5/6, the denominator would be 0. So this value makes the expression I was given undefined. Now every other value would be fine. You could replace p with anything else, and this would be okay. You'd have a defined value. All right. Example 3. Numerator is n minus 3 divided by, denominator is n squared plus 2n minus 8. So again, when we're asked to determine the values for which a fraction is undefined, the only expression we're really concerned with is the denominator. Right? Our question is always going to be, for this kind of problem, when is the denominator n squared plus 2n minus 8 equal to 0? And whatever values solve this equation, those are values I can't plug into the fraction because I'll be dividing by 0. Alright, so this is a polynomial equation. Right, everything on one side, 0 on the other. And then I would want to try solving by factoring first. Now if you know this is a quadratic, right, degree 2 polynomial here. So if you know how to complete the square or solve with the quadratic formula, be my guest. But I'm going to solve this by factoring. This n squared plus 2n minus 8 would factor to n plus 4 times n minus 2. And now we have a product equal to 0. And by that thing called the zero product property, right, the only time a product is equal to 0 is when one of the factors is 0. So either n plus 4 equals 0 or n minus 2 equals 0, and then you're solving each of these. So n equals negative 4 here, and I'll circle that. N equals negative 4, or n equals positive 2. I'll circle that as well. Both of these values are what they're asking me for. Alright, so this expression, this fraction, I could plug in a value for n that's any number I want, except negative 4 or 2. Alright, because if you plug in negative 4 for n, the the numerator will be negative 7. Numerator can be anything, but the denominator will be 0. Same thing if I plug in positive 2. The numerator, it doesn't matter what the numerator is, right? The numerator will be negative 1 though. But the denominator, what we're dividing by, will be 0. So so n can be anything except these two values, right? Negative 4 or positive 2. Alright, so again, hopefully this is pretty simple looking by now. Alright, example 4. This expression has, two variables, m and n. We have the numerator 10 times m divided by denominator 11 times n. And just like in example 1, I could replace m and n with any numbers I want. Except for 1. Except for one value. You'll see what that value is in a second. I bet you can see it already. But I could replace m with 30 and n with negative 12, or m with 10 and n with 5. Just whatever you wanted, except this, right? So again, the same question every single time. When is the denominator, which is just 11 times n, when is that denominator equal to 0? And simple enough, divide by 11. That happens when n is 0. So I can replace m with anything. I can replace n with anything as well, except 0, because that will make me divide by 0, which will make this expression undefined. Alright, simple enough there. I'm doing the same thing for all of these, just remembering that I can't divide by 0. So again, we're saying same instructions, determine the values for which the rational, it's all the exercises in this video. We're determining the values for which the fraction is undefined. So number 5, right, 6y plus 13 is the numerator, divided by 4y minus 9 is the denominator. And again, I'm asking this same question each time. When is the denominator, right, 4y minus 9, when is that equal to 0? And whatever the solution of this equation is, right, the denominator equal to 0, those values are not allowed to be plugged in because the expression will be undefined. Simple enough here, add 9, divide by 4. So y equals 9/4. This value would make the expression undefined, right? Plugging in 9/4 for y would give you some number in the numerator, who cares, right? And then the denominator would be 0, and that's bad. But I could replace y with any other number I wanted. Any number except 9/4. Alright, example 6. We got b minus 8 in the numerator, divided by b squared minus 36 in the denominator. And the same question for all of these. When is the denominator, b squared minus 36, equal to 0? And whatever solutions this equation has, those are the values of b I can't use. Right? Those are the values of b that will make this expression undefined, that will make me divide by 0. Well, this is another easy polynomial to factor here. This is a difference of two squares, b squared minus 6 squared. So that'll factor to b minus 6 times b plus 6. And then we still have equals 0. And now I have a product equal to 0. Right? By that 0 product property, either one of these factors is 0. So either b minus 6 is 0, or b plus 6 is 0. Adding 6 to both sides here gives me positive 6. Right, so I'll circle that. Or subtracting 6 here, b equals negative 6. Circle that. These two values are not allowed to be plugged in for b. Alright, because if I plug in 6, you get negative 2 in the numerator, 0 in the denominator. That's bad, right? The expression's undefined. If I plug in negative 6 for b, we'd have negative 14 in the numerator, but again, 0 in the denominator, which is not good, right? That's an undefined expression. Okay, same thing for 7. Example 7, numerator is 4 times x squared times y. The denominator is 3 times y. So same question at the beginning of every single one of these. When is the expression in the denominator equal to 0? And whatever solves that equation is not allowed to be used. Well, simply dividing by 3 here, we're seeing that y equals 0. This value will make this expression undefined, right? If I plugged in 0 for y, the numerator would be 0, that's okay, but the denominator would also be 0, and that's bad, right? That's undefined. Now, this is the only value that will make it undefined, meaning I can plug in anything for x I wish, and anything for y I want except 0, right? So I could plug in 10 for x, 15 for y. I could plug in the square root of 3 for x and 1/2 for y, and this expression would represent some defined value. The only one that's not good is when I choose y to be 0. Okay, example 8, and same deal. Numerator 3x minus 2, denominator 2x plus 1. And I'm asking the same question every single time. When is the expression in the denominator equal to 0? Because that will be bad. That will make my expression undefined. Simple enough. Subtract 1 divided by 2. So when x equals negative 1/2, this expression will be undefined. So I could replace x with anything except negative 1/2, and it would be a defined value. I could replace x with 100, with 7, with 13, with 3/4, and with pi, and it would be a defined value. The only one that's no good is negative 1/2, because it makes me divide by 0. Alright, and the last 4 examples, the same as the first 8. I'm asking the same question every single time. Example 9, the numerator is u minus 1 divided by, denominator is u squared minus 3u minus 28. Same question every time. When is u squared minus 3u minus 28 equal to 0? When is the denominator equal to 0? And I have another quadratic polynomial here that's very easy to factor. This would factor to u minus 7 multiplied by u plus 4. And when is this equal to 0? And we have a product equal to 0 using the 0 product property. Either u minus 7 equals 0, or the other factor, u plus 4 equals 0. And solving each of these gives me the two values I cannot replace u with. So u equals 7 would make this expression undefined, right? Would make me divide by 0. Or, u equals negative 4. So either one, right? Either one of these, when I plug them in, would make me divide by 0 and make the expression undefined. Now I could replace u with any other number but these two, right? 5, 10, 15, 100, 1,000, 2/3, whatever. Just so long as I don't replace u with either of these, I'm fine. Example 10, again a pretty simple one. Got 5pq squared in the numerator, divided by, and then 9q in the denominator. And the same question every single time. When is this expression in the denominator equal to 0? And solve 9q equals 0, divide by 9, you get q equals 0. And there you go. Very, very, very simple. I can replace p with anything I want. And I can replace the q's with anything I want except 0. Okay, almost done here. Example 11, numerator is 7a minus 4, denominator 3a plus 5. So I'm trying to find values of a for which I will be dividing by 0. Same question every time. When is the denominator 3a plus 5 equal to 0? Solving this, again, simply subtract 5, divide by 3. A is negative 5/3 there, and there it is. If I replaced a with negative 5/3, the numerator would be some number. Who cares, right? But the denominator would be 0, making this expression undefined. So I could replace a with any number I wanted except negative 5/3. And finally, example 12, 1 is in the numerator, divided by x squared minus 4 in the denominator. And it's the same question. When is the denominator equal to 0? And I solve this equation. Another quadratic. And it's another one where this quadratic polynomial is a difference of two squares, right? X squared minus 2 squared. So that'll factor very simply to x minus 2 times x plus 2. And this is set equal to 0 using the zero product property, right? The only way a product is equal to 0 is if one of the factors is 0. So either x minus 2 equals 0 or x plus 2 equals 0. Solving each of these gives me the values I can't plug in for x, right? It gives me the values that will make this expression undefined, right? That will make me divide by 0. We have x equals positive 2 from this first equation here, or x equals negative 2 from the second equation. So I could replace x with any number I wanted except 2 or negative 2. Because if I replace x with 2 or negative 2, the denominator will be 0. I'll have 1 divided by 0, and that's bad. That's undefined. Okay, so again, simple enough, I hope. Every single one of these is exactly the same. You ask the same question every time. When was the expression in the denominator equal to 0? And once you solve that equation, those are the values that make the expression, make the fraction undefined, and those are the values that you can't plug in. All right. So hopefully watching me go over these 12 examples here help you out when you're working on similar problems. And thank you very much for watching.